Welcome to episode 8 of the Science for Progress podcast. This is the first episode after our summer break, and I hope you missed us. For this episode, I spoke with Dr. Bart Geurten about cognitive biases. What are cognitive biases? Why did Bart make a whole seminar on this? What is the impact of cognitive biases on science? And what role do cognitive biases play in society? Bart and I have been friends since college, and this year we met in Australia, where we both attended the International Congress of Neuroethology, and that's where we recorded this conversation.
Hi, I'm Bart Geurten, and I'm by no means a cognitive scientist, as I usually work with very small animals, and I'm most interested in locomotion and motion vision topics. So this is basically only a side project of mine, and so I apologize here to all psychological scientists and all human cognitive scientists, and don't rip me a new one for all the mistakes I make.
An important concept that we need to understand before we go deeper into this conversation is the concept of heuristic.
A heuristic in this case means a shortcut, a mental shortcut to solve a problem. And they per se are not bad or not be avoided because we need them a lot to cope with the reality. But if you would think about each problem that you have to face every day in depth, you couldn't get anything done. You might not even proceed after your breakfast because you have to ask yourself, do I want to eat cereal or bread? And then if you really want to answer this question the best possible way, you might think about your whole dietary efforts. How much am I going to do on physical work before I actually approach the next meal? Where's the better food intake? And so we take this simple mental shortcut to pick one of those and not have to think an hour about our breakfast.
Is it kind of like optical illusion?
Sure. So the easiest version, which you might include into the links of this podcast, is the liar illusion, where you actually have two horizontal lines with fins attached to it that either point inward or outward. And these fins then give you the illusion that the line would be shorter or longer. That's a typical visual illusion. And cognitive illusions are pretty much the same thing, but you're now not targeting a sensory system, but cognition itself. And basically this, it's not really an error, but more of a strategy that leads to a misconception.
So I myself better understand this concept if I think of pattern completion. And this pattern completion is a mechanism where your brain takes incomplete information and creates something out of it. In the original Kanizsa Triangle illusion, there's 3 Pac-Man-shaped figures that are oriented in a way that it creates the illusion as if it were 3 circles that are occluded by a triangle that is not outlined and has the same color as the background. But I got it backwards, so here we are talking about 3 pyramids occluded by a circle. But I will put the correct image into the show note.
In this case, it's our primate ancestry that gives us the possibility to see the 3 pyramids. But in our case, the 3 pyramids are what we think that should be there. But actually, this is already maybe a form of availability bias. So again, psychologists don't hit me with that. It could be some kind of availability bias in which we so this is one of the first heuristics they described, in which we take part of our memory or a solution that is available because it's fresh in our memory or it's very significant in our memory because we actually combined it with a strong emotion or something like that, and take it as the first possible solution. It's a bit like a lazy mind grasping the first thing that you can see and say, this might be the solution that we are actually looking for, in contrast to really sit down and think a long time about it.
So that is the idea of Thinking Fast and Slow, which is the book of Kahneman, right?
Yeah, so he describes 2 different systems or 2 different modes of operation. In one where we have snap ideas. Basically, if you show somebody a picture of a dog, he says dog, and if you show him one of a car, he says car. And this is what he called system 1, the autonomous cognitive system that can fastly produce all these different informations, and there's system 2, which is like effortful and stresses us out to think about. A very simple example that might be interesting is one that is in the book about the following question. There's a bat and a ball for $1.10, and the solution, the question that you then ask is, if the bat is $1 more expensive than the ball, what's the price of the ball? And the immediate answer that pops into my mind, at least, and I'm pretty simple, is it's 10 cents. Like, the bat and the ball are $1.10. The bat is $1 more expensive than the ball, so the ball must be 10 cents. But that actually makes no sense. If you really think through it, in this case, bat and ball should be $1.20 together. So the real solution to this problem is 5 cents. The ball has to be 5 cents expensive because bat and ball together are $1.10, and it's more than $1 expensive. Yeah, and if you think about that, this is like the two different systems competing against each other. And here's a lot of interesting, like, the book is brilliant, and you have a lot of interesting examples of those where these two systems actually collide, where we want to give a fast and easy answer, but in reality we actually have to think more about it. And one of the strategies that I found most interesting from the book is that actually our mind tends to solve different problems than the ones that are really posed to them. So if you have a complex problem that's posed to you, you tend to solve a different problem that is easier to solve and that might also deliver the right answer.
Can you give an example for that?
Now you put me on the spot. What would be a good example of that? A very good example of that is a very famous example. It's the Linda example. Again, sorry to all the psychologists. You can now spool forward for like 2 minutes. Linda example is the description. In the Linda example, which is maybe their most famous example, you get a description of a young lady, which I can't recall completely, but it's basically the description of a very young, bright woman that is invested in social justice topics and is against nuclear weapons, etc., etc. And at the end, people are asked, is Linda a bank teller, or is Linda a bank teller and a feminist? And again, this example works perfectly for me. My mind seems to be pretty lazy. I said, she seems to be like a feminist. Like, really, she has all the like hallmarks of a young woman. And in reality, this is not the question that we're asking. We're asking a Bayesian probability question. And everybody who knows Bayes knows that if you have like conjective probabilities, like Linda could be any Linda, like from whatever, a carpenter to a neural surgeon, there's a small probability that Linda is also a bank teller. If we now connect that with another probability that Linda is either feminist or not, it's obvious that the connected probabilities must be smaller. So, or if you think about it in a Venn diagram, all Linda bank tellers will be the larger circle, and Linda bank teller feminists would be in that small in this larger circle. But that's not how our mind works. At least me, I'm not going to like the Bayesian probability thing and think through like all the possibilities, but I hear a story and the story is very available, so I solve the different problem. The different problem is, what can I catch out of my memory that would describe this person? And then, again, availability bias, I jump to the easiest conclusion, she's a feminist, the other one is not a feminist. Obviously, this is more probable.
What is framing in this context?
Framing is the idea that I give you a context, and out of this context you derive your own, you derive a wrong solution maybe. We did this actually with our students, and we gave them like a 10-second time window to answer the question, how big is how would you approximate the number of the term 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9. Against the other group had the same question, but the numbers were ordered highest to lowest. And the differences are remarkable. Like, the group that had the increasing number would approximate the result of this calculation by around 2,500, The other group approximated it by around 10,000. So this seems to be very consistent. Like, we tested this with a lot of different students, and it's also like shown and published. So no merits there to get. But it's a fun thing, and it teaches you how you approximate values and how wrong you can be. And availability is, in this context, I guess, like also the information that is freshest in your mind. Like, the higher numbers are actually making this much, making you overestimate the result of that.
What else would be a typical cognitive bias that you can have?
One of the typical biases is the base rate fallacy. A base rate fallacy means you don't take into account that there's a base rate probability for something to happen. Make an easy example would be Steve, which I like as well. It's from the same book, Thinking Fast and Slow. And Steve is described as a very silent and tidy soul that likes to think about small problems, that needs to actually have a neat and tidy surrounding, and that is very introvert but not rooted in the real world. And then after this description, which is much better in the book and more concise, people are asked, is Steve a farmer or a librarian? And also my students had to answer this question, and the overwhelming population says he is a librarian, which fits our idea about librarians. So I checked on more than one statistic database how much farmers there are in Germany and how many full-time librarians there are. Full-time librarians is like in a couple of 10,000s. Farmers is just a million people like full-time working on a farm. So statistics tells us there are more tidy and silent souls on tractors right now in Germany than there will ever be behind a librarian desk. This one thing blew my mind, because I was sitting there and thought, like, for the first time I understood like probability in a very visceral way. Like, I could see all these farmers being deep thinkers on their tractors, and all these more rusty librarians in front of me. But on top of that, this is a base rate fallacy. This is a classic base rate fallacy, because you hear this description and you certainly think of somebody who could easily work in a library, but the chances are not that way. And base rate fallacies are also present, for example, in the gambler's fallacy. The gambler's fallacy is an amazing fallacy which you think that because something happened, like, for example, you're on a roulette table and red comes, that next thing should be black. There's one incident in Macau in the 1920s, 1910s, where about 20 to 30 times after another, the black came on the roulette table, and in this night, millions of francs were lost by gamblers because they thought there was so often black, red should appear. But the chances, as any mathematician can tell you, are always 50-50 if it's red or black. So just because something was a few times after another doesn't mean that the other thing shows up.
Going back to Steve and whether he's a farmer or a librarian, isn't that also a framing problem? Because the way you asked the question, I felt like the probability should be 50-50 whether he's a farmer or a librarian.
Of course, this is also a framing problem. And this is where I have again to admit that I'm not an expert on that field. And I guess you can interpret this in both directions, and if not, just correct me somewhere in the comments. But the base rate fallacy here is so clear. So I would say it's also an availability problem. Like, I heard this description of Steve, and Steve sounds like somebody who would be good with books and who likes to have a clear system of the world. And yeah, but on top of that, the thing that you mostly ignore in this case is that there's just only a few farmers in the world and a lot of there's only a few librarians in the world and a lot of farmers. I guess you could easily construct more examples like that with like less directed or framed questions or descriptions, where you just say, what's the chance that he is a heart surgeon against a general practitioner? And I don't know the statistics for that. Again, correct me if I'm wrong, but I guess there's more general practitioners in a given country than heart surgeons. And maybe with with some simple coins of information, like he has very steady hands, or she's very concentrated on single-minded tasks, we could steer the population in one or the other direction.
Bart had actually given a lecture to his students at the University of Göttingen. So I asked him about that. You talked about this with your students, so this is part of your teaching. This is not part of your research, right?
Yeah. Just by chance, I started to look into Danny Kahneman's and Amos Tversky's work about heuristics and biases, and thought that makes actually a really good neuroscientist lecture in the Uni Göttingen's D&B master, which is for developmental and neuronal biology. And yeah, so we started making a new lecture, which included all these heuristics and biases you might already have heard of, and students really reacted positively to that. Like we have a small quiz in the beginning where we have like trick questions that actually kind of uncover these biases. And yeah, and then we go through all these different aspects and talk to the students about how this comes to pass. Obviously, Tversky and Kahneman didn't concentrate on like neuronal features and brain regions or stuff like that, but they showed in a very nice, like, ethological way how our brain works and how we are tending to these different errors. One of the principles I learned from my supervisors, like David O'Carroll, Martin Egelhalf, is to understand the system, you break the system. You drive it into a situation where it actually makes a mistake, and by analyzing the mistake, you know how the system works. And basically that's what Kahneman and Tversky did. They always driven like our cognition into a position where it makes an error, and thereby unmasked the underlying system and the underlying strategies. Tversky and Kahneman are really enormous giants of science, just by asking the right questions, thinking about the right problems. And all their papers are full of math and full of a lot of like deep thinking about how our mind works. And it's a completely different approach. It's another one, like, I measure the calcium signals of flies under certain circumstances, and thereby I can like think about the small building blocks that make a brain. And they come from the complete other side, and they just ask people questions, and they can still gain the same insights into the brain, and even deeper ones that can be easier applied to our own life. I fear nobody ever is going to see one of my calcium traces and say, oh, this is going to change my life. No, but Kahneman and Tversky actually did simple but immediately clever, genius questions that then led to that.
So what do I search for if I want to find the scientific contributions of Kahneman and Tversky?
I think prospect theory is like the core to all these things. And there's a very simple example that explains prospect theory very nicely. So if you have the chance, if I would give you the chance to have either 1,000 euros cash or a 50-50 chance to win nothing or 2,000 euros, what would you take?
I would take the 1,000 euros, I guess.
Yeah, and so do most people. I think 80% answer this question with like, I take the 1,000 euros. I would too. So, other question. I come to your home and I steal 1,000 euros. Or you get a 50-50 chance that I steal nothing or 2,000 euros. What would you take?
Okay. Yeah, I would take the chance in this case, right?
Yeah, me too. But actually, if you think for like all the math nerds already have figured it out. I asked the same question two times, but just with different signs. One time we talked about like a 50-50 chance to get 2,000 euros and 1,000 euros safe, or to lose 2,000 euros or lose 1,000 euros safe. And interestingly, the most of our, like all people, scientists, laymen, everybody answers this way. We are keen to take chances when we are losing, or when we have to take a a negative choice, and we are keen to take safe things when we take a positive choice. And interestingly, if you would graph that, you would actually see that the curve for negative choices is very steep, and the one for positive choices is more flat. And that's basically the whole idea about prospect theory. If you
Sorry, what would the curve look be like? What do you plot above against each other in the flat and the steep curve?
The probability to take a chance, and the on the y-axis and on the x-axis, the amount of loss or win. So, and that's actually quite funny because we see that often enough in the real world. Like, if you have, for example, a job that you like, you are not willing to change for a few hundred euros, for that matter. But this is only reached at the real end of the curve. Like, your job is already paying nicely, you have nice colleagues, somebody says, here's 50 euros more if you work for me. You're not going to do that. But like in the beginning of the curve, in the origin, like basically you and I, when we were still studying and I was like working 3 jobs at the same time, if somebody would give me 50 euros more, I would say, yeah, I swapped from being like a waiter to whatever else I worked, mover. That was totally the case. Nowadays I wouldn't change my lab for 50 euros a month, but no. I would change it if my choice is between giving somebody food or move. I don't care for either of that, and suddenly these small values make a very big difference. The other point that I want them to get out of this is science is always effortful thinking. And you easily step into one of your own heuristics, and the problems that arise out of heuristics are called biases and are prone to that bias if you don't think deeply enough about your own results. I often fall into the trap of availability heuristic, and then I have an expected result and it comes out of there and I think like I'm done, but actually this is the point where I actually need to think a lot more. Think about like, why is this expected, and is this really the expected result?
So like if you had a different background, you would expect a different outcome, or you would expect the same outcome but with a different explanation?
I guess so. I mean, what's obvious is that heuristics and biases are global and everywhere. So I guess the way I was trained as a scientist somehow makes me a victim of my own background. Like very often when I remember sitting down in one of these conferences, neuroethology conferences, and somebody else presented work, and I was sitting there with an old supervisor of mine, and we both were looking at each other and thinking like, why aren't they asking this question? This is the most important question. And they never did, and they never should have, because why? This was interesting to us, but this is availability bias. We see data, and I directly see the hypothesis and maybe the paper that could come out of there. But it's just my point of view, my frame of reference that I take into the session. And very often at the end of a discussion in the scientific what's called presentation, you see this frame of reference coming to bear. Like the professors ask, or the scientists ask questions from their frame of reference and transverse the results of the other scientists into their frame of reference. Which in a way is good because this opens up new fields, but which is sometimes also not relevant for the other scientist because this is just not what he is interested in. So sometimes it's more helpful for actually the listener than the presenter to have the discussion.
Do you think this is a problem or a feature in peer review? So in science we look at papers from different authors and we're supposed to judge their merit or their validity. Do you think that these kind of biases have a positive or a negative effect in peer review?
I think we both agree that a lot of peer review is really, really broken and needs to be fixed. Yes. But exactly, yeah, that's a problem. Like if you downgrade a paper because you cannot change your own perspective into that of the scientists that are actually involved, this is problematic in a way. Like it's also good because you find like objective errors, but if we talk about like scientific merit, like how important is this paper, can it be published in this kind of journal, like, is this good enough for the journal? This is a real problem. Because for the love of God, I cannot judge a mouse paper because I'm not really interested in mice. Even so, that's a cool, like, if you're working on mice, I'm sorry. If you...
Like me.
But it just doesn't tickle my fancy. And if I actually judge mice paper, I take a strong personal effort to think about that in the context of the people who work on vertebrates and say, okay, this might be interesting. And I often, in my personal peer reviews, I just don't think about if this is good enough for the paper. I always assume it is good enough, and most of the science is good enough for any paper. But yeah, that's a real problem. We need to like skip our own frame to look at the data of somebody else and judge if this is an important article. On top of that, I very seldomly read in my life an article where I could say, this has no relevance. I'm at a problem to figure out, to name one where I could say this is not relevant to anybody.
So I was thinking, and I'm not sure if that's the same the same topic, but when you look at the news and how they report scientific controversy, you always find you have one guy who is, for example, a medical doctor, and he's there to announce that vaccines work. And then on the other side of the table, you have a YouTuber. And so these opinions are presented as equal, right? But they're not.
Yeah, that's not directly framing, but that's one problem. But also here, availability bias or heuristics play an important role. So the medical doctor usually refers, like it's proper to do, to statistics, to journals, to like tests that they made, and maybe even refers to like statistical data. And this is for laymen hard to catch on to. And the YouTuber usually says, my kid got autism by vaccines I saw it with my own eyes. And this is the availability problem there, because it's so easy to imagine seeing your own kid get sick instead of like thinking about like a graph and standard error bars and like statistical differences. And here availability plays an important role. The argument of the anti-vaxxers are more available to us than to the layman than statistics. And again, vaccines work.
So going back to the framing, is there a prominent situation right now that you can use as an example for framing?
Yeah, at least, for example, news and I think in Germany at the moment, it's a bit, or in Europe in general, it's a bit of a war of words. Like, for example, in Germany and all of Europe, we're talking about the immigration crisis. And if you think about that, that's kind of weird, because Germany has not enough young people to support our like social systems. And this is, you could view that as a total different frame, like population increasement chance, for example. And that sounds nice, doesn't it? Like population increasement chance, like they are going to save our rents, they are going to save our pensions, they help uphold our social systems.
Or just demographic chance, or
something like that. Like demographic chance. The Democratic Chance Initiative of Chancellor Merkel sounds much better than the immigration crisis of Chancellor Merkel. And this is exactly such a framing problem. Like how I do frame that, which language actually wins over the other, decides how the societal, social discussion works. Like our society discusses at the moment immigration problem. It never discusses immigration chances. Like immigration, like if you're a nerd like me, you played Civilization throughout your childhood. The best thing that could happen to you is more people. Like this would save your civilization. And we now get more people, and everybody's like really scared what's going on. But in reality, we could also be really happy about that and say, we didn't know how to fix our pensions, we didn't know where we could get the workforce, and now people are coming into the country. Great. This is a framing problem, of course. And this also in this way, language can actually be decisive about like how society works, isn't it? See, we came back to the title of your podcast.
Well done. Yeah. Isn't there also an availability problem? I'm just thinking of it, and now that we've been talking about this comes up. You find it everywhere you look. People talk so much about refugees that you think there must be a whole lot of them. What do you think is the probability of a person being in Europe and being a refugee?
Now that you've said it, and I'm primed to really think about it, I have basically no idea. Less than 5%.
Yes, less than 5%. It's actually so when there was the huge crisis, quotation marks here, in 2015, we had 1.2 or 1.5 million refugees, and over 500 million people live in Europe.
I have to admit that, like, when I said below 5%, I at least thought it might be 2 or 3, but this is just less than 1%, is it?
Yes.
Yeah, it's ridiculous. And that's exactly what framing does to you. Like, it did to me, that I thought it's maybe 2-3% refugees, but after now seeing the numbers, like 500 to 1.5, this is hilarious, actually. Like, that we even discussed this nonsense. There you see what actually framing bias does to a society. We thought that we are in a crisis where, like, the real crisis is down in the Mediterranean, where people actually drown and die. And we, like, from my point of view, we're not doing enough to like, help them and get people into the country. And we don't lose anything by getting more people. That's at least my opinion.
How did you first learn about this topic?
That's a funny thing. So basically, Michael Lewis got me onto this topic. He's a writer, and he writes excellent about mathematics. And this now sounds really weird. Like, don't get me wrong, most of my time I read cheap fantasy literature or sci-fi stuff. And for once in a while, I had the feeling that I have to read something more with more impact on life. And I stumbled over Michael Lewis, who is an amazing writer if you have, like, a really complex topic and you want it to be presented funny and like a real page turner. Michael Lewis wrote about, like, for example, Flash Boys is a brilliant example. This is about high frequency trading and the New York Stock Exchange, and how it works and how the people are involved in there, and also about how's that one? The Big Short is, like, I think his most interesting book, where he wrote about the housing crisis in America, and how some traders actually profited from the housing bubble bursting. And I think most Americans know him for Moneyball, which is about I forgot actually the baseball team, which is about a baseball team that has actually no really mediocre funds, but always comes up top in the list, in the league, and how they employ, like, how they avoid all these biases. And, like, he actually was on a conference or somewhere where somebody told him, like, where the people said, yeah, it's totally cool that he writes always about, like, avoiding these heuristics and biases, but he seems not to know them. And then he started to write a book. It's called The Undoing Project. And if you have no clue about psychology and you're a bit afraid of, like, reading a lot about math and cognitive sciences, I would totally suggest The Undoing Project. It's part biography of Amos Tversky and Daniel Kahneman, and to a large part, like, how their science works, masked in wonderful writing that makes it a real page turner. And I first read that, then I gave it to one of my colleagues, Herbert Grass, who said, like, that's too much fluff. Read Thinking Fast and Slow by Kahneman. This is much easier, and the information content is much higher. So if you need a lot of information content, are very smart, read Thinking Fast and Slow. If you want a more entertaining style, maybe then it's Michael Lewis's The Undoing Project. you can read anything from him. He's fantastic.
And I guess with this we end this conversation. It was nice talking to you.
It was very nice having me on your podcast.
Yeah, absolutely. And we should do that again.
Yeah, thanks. Goodbye, listener.
Thanks for listening. I hope you enjoyed this episode. The podcast is available through RSS feed or on iTunes or Stitcher or Blueberry. So you can subscribe and follow us. You can also follow us on Twitter @Sci4Progress, and our website is scienceforprogress.eu. On Twitter we also administrate a rotating curation account where every week there is a different curator talking about topics from within and around academia and the connection or the interface between academia and the public. And finally, there is a Facebook page. You can find us there also under the handle @Sci4Progress. Bye bye.